Hello guys, in this video I'm going to continue again the discussion of Bode plots. We're going to see an example here of a low pass filter. Okay, so in the last two videos we see like some standard forms, what they call standard forms for h of omega, in which we can easily draw the Bode plot. Here we have more sophisticated form, which is basically the practical ones. Okay, but to draw them, we're gonna using Bode plots, we're gonna transform them into standard forms. So far we studied four standard forms. When h of omega equal to k, g omega to the power of n, g omega to the power of minus n, or 1 over g omega to the power of n, a simple zero, which is 1 plus g omega divided by omega c to the power of n, or simple pole, 1 divided by 1 plus j omega over omega c, the whole to the power of n. What we have here is not 1 plus something, it is 100 plus g omega in the numerator, and the numerator is 10 plus g omega. So we don't have like a constant by itself, like k, or g omega by itself, or 1 plus g omega over omega c. No, we have something, not 1 plus g omega something. So we want first to be able to draw them using Bode plots, to transform them in what's called a standard form. Okay. So we know how to deal with 1 plus j omega over omega c. We know how to deal with that. Okay. So that's what we're gonna do. We're gonna transform each term in the numerator or denominator into something like 1 plus j something. Okay. In order to do that, we're gonna take like from the numerator the 100 as a common factor. So 100. This will give us 1 plus j omega divided by 100. And we're gonna do the same in the denominator, but we're gonna take 10 as a common factor. So 10, 1 plus j omega divided by 10. Oh man, we can't transform it. That's basically that one. And that's basically that one. Also, omega c in the numerator is different from omega c in the denominator. Okay? We can simplify further. So 10 can go with 100, gives you or leave you with 100. So let's write it in this way. 10, 1 plus j omega divided by omega 100 multiplied by 1 divided by 1 plus j omega over 10. Oh, what is that? 10 is like k, the constant case. Oh, what is that? That's exactly like a simple zero with n equal to 1 and omega c equal to 100, just to compare that guy to that guy. And what's that? That's a simple pole. Simple pole with n equal to 1 and omega c equal to 10, just to compare them to each other. Okay. Now the trick is that the magnitude of h of omega, and remember we plot the magnitude, not the actual function. When you have h of omega equal to something multiplied by something multiplied by something, like let's do it in a more formal way. If you have like h equal to some complex number z1 multiplied by some complex number z2 multiplied by some complex number z3, then the magnitude of h is equal to the magnitude of z1 multiplied by the magnitude of z2 multiplied by the magnitude of that's Mr. z1 here, that's Mr. z2 here, that's Mr. z3. So that's equal to the magnitude of 10 multiplied by the magnitude of 1 plus j omega divided by omega 100, which is omega c in that case, multiplied by the magnitude of, I'm gonna write it in this way, 1 plus j omega over 10 to the power of minus 1. Okay. And remember, when we do the Bode plots, we do 20 log. So 20 log the magnitude of h of omega equal to 20 log all of that. Again, let's go back to the principles of logarithmic. 20 log magnitude of h here. When you take 20 log 1, 2, 3, you can add them. 20 log 1 plus 22 plus 20 log. That's what exactly we're going to do here. So that's 20 log 10. Of course, magnitude of 10 is 10. Log plus 20 log 1 plus j omega over 100 plus 20 log 1 plus j omega over 10 to the power of minus 1. Okay, so that's equal to 20 because log 10 is 1 plus 20 log 1 plus j omega over 100 minus 20 log 1 plus j omega over 10. Okay, then we draw each one. We used the two in the previous video to draw like one form. So we plotted the k by itself. The first case, we draw g omega by itself, 1 over g omega or g omega to the power of minus 1 by itself. 1 plus g omega over omega c to the power of n and the power of 1 by itself, and the simple rule as well. Now we have a more sophisticated case. We have like 3 terms. So the Bode, basically brilliance here. That since each one of these plots that we did before is very simple, like straight lines, right? Linear lines. It's easy to add lines together. So we're gonna draw or plot each term by itself. So we're gonna have 3 plots. 1, 2, 3. Then we're gonna add them together. Okay, I'm gonna do each one by some different color. So bear with me. It's gonna be easy. So as we used to, we have our y axis linear scale, and when you take log something, it's gonna be in decibels. So this is 0 decibels, 20 decibels, 40 decibels, 60 decibels, minus 20 dB, minus 40 dB, minus 60 dB. Okay. But our x-axis, which is omega axis, so we're gonna draw here a 20 log, the magnitude of h of omega, and the variable here, omega. Okay. We're gonna do, for example, 0.1 here, 0.01, 0.1, then 1, then 10, 100, 1,000. Let's take 10K, 10,000. Okay. Now, let's draw number 1 with yellow fruit line. This is easier, the easiest one. 20. So 20 dB basically. So at 20, we're gonna do like a straight line like that. That's number 1. Okay. Now let's draw number 2. For drawing number 2, let's analyze it. Let's take it to the side here, 20 log. Just to review, 1 plus j omega over omega c. For that symbol 0, okay, like this case here, symbol 0. What we did, we divided the whole like a plot into 2 cases. Number 1, omega less than omega c. In that case, omega c is 100. So I'm gonna remove the omega c and put 100. That's omega less than 100. In that case, h or 20 log h of omega, it's gonna be 20 log approximately 20 log 1, which is 0. Okay, number 2, omega higher than, much higher than omega, which is 100. Let's have a couple of points. At omega equal to omega c, that will be 20 log 1, which is 0. Omega equal to 10 omega c, that will be 20. Omega equal to 100 omega c, that will be 40, and so on. Okay, remember omega c here is 100. So that's basically 1000 here. That's basically 10,000. Okay, and omega equal to 100. So let's do that. So let's have another color, like not orange color. So for all points less than 100, h of omega is 0. Okay. Now, when omega equal to 100, we're going to go to number 2. We have still 0. Omega equal to 1000, we have 20. Omega equal to 10,000, we have 40. Equal to 200,000, we have 60, and so on. Okay, good. That's number 2. Function number 2. Number 3 now. Let's go back to our number. So for number 3, which we have 20 minus 20 log magnitude of 1 plus j omega over 10. This is fine. Again, this is again simple. This is simple rule. Okay. The actual case with 20 log 1 over 1 plus j omega over 10. So we just bring it to the numerator. We put minus 1 to compensate for that, and the minus 1 goes to 20, makes it minus 20. So 2 cases: omega less than 10, that's 0. Omega larger than 10, much larger than 10 actually. So let's have a couple of points. Omega equal to the omega c equal to 10, that will give us 0, 20 log 0. Omega equal to 100, 10 omega c, that will give us minus 20. Omega equal to 1000, that will give us minus 1, and so on. If you don't know how we get that, just to go back to our previous videos. Gonna review a simple one here. So basically, when omega much larger than 10, okay, we can approximate minus 20 log 1 plus j omega over 10 into minus 20 log j omega over 10. Magnitude of j omega over 10, magnitude of j is just 1, so that's equal to minus 20 log omega over 10. Okay, and now you can put like 10, this will be 1 is 0, 100, 10 is 1, so minus 20, 1000, like 100 will be 2 multiplied by minus 20, minus 40. Let's draw that. Let's have another color, like green, for example. Red, whatever. So for omega less than 10, it's 0. That's 10 here. We have here in that area from 0.01, 10, the orange and the red both are zeros, but the yellow is 20. Now for higher than 10, at 10 is still 0. Then at 100 minus 20, we go down. At 1000, it's minus 40. We can continue, by the way, at 10,000, it will be minus 60. Then you connect that. Like this. Okay. So now let's combine. This is number 3. Okay, that function. Now let's combine all of these together. Okay, let's do this in green, for example. I said it's easy to add up or sum up like simple plots, like straight lines like that. There is no curves here, so it's easy to add them together. Okay, what we're gonna do? We're gonna first. It will be at the end of the day straight lines, and for any straight line to draw it, we need just 2 points. We have 2 points, and you belong to the same straight line. You can just connect them together. That's a straight line. That's what we're gonna do here. Okay, so we're gonna choose or pick like the changing points. Okay, the start, for example, that's number 1. At that point we have a change. At that point we have a change. Okay, at that point we have a change. Then this guy will continue forever like that. This guy will continue forever like that. This guy will continue forever like that. There is no changes afterwards. So let's see. At the first point here, at omega equal to 0.01. Remember, we don't start here from 0. Okay. So we have 2 zeros. The 3 is 0. And the orange number 2 is also 0. But the yellow one, it's 20. So basically 0 plus 0 plus 20 will give you 20. So that's the first point on our the overall Bode plot. Second point at 10, this one here. The red is 0, number 3. The orange is also 0. And the yellow is still 20. So 0 plus 0 plus 20 will give you 20. Good. At number 3 here, this one. The yellow is still 20. The orange is 0. Number 2 is 0. But the red is minus 20. So minus 20. So 20 plus 0 minus 20 will give you 0. Oh, we have a 0. Let's now take the fourth point. Okay. The orange is 20. The yellow is also 20. The red is minus 40. This point is minus 40. 20 plus 20 is 40. Minus 40 is 0. Let's continue. Continuing is very easy. So that's here 40. That's here 20. And that's here minus 60. 40 plus 20 minus 60 is also 0. It will be 0. And if you continue, it will be always 0. Always 0. Okay? Always 0. So let's now connect these green dots together. So, like that. Then, like that. And like that. And until infinity. Oh. So now with the green lines, basically, this is the Bode plot, the final Bode plot. The green is final Bode plot for H of omega. H of omega, which is that guy here. Okay, it was very sophisticated. Now look how we could approximate it easily. Okay, that's basically the Bode plot. So, but before we finished, basically we finished. But just before we move on, and end this video and go to another example, let's remember this is the circuit. Okay, that's a transfer function of a circuit. H of omega might be V output over V input, or I output over I input, or I output over V input, or V output over I input. Something in the output divided by something in the input. Okay, let's take the easiest case to understand, which is usually the voltages. H of omega equal to VO over V input. E.g., example, H of omega equal to VO over V input. Remember, all of them are function of omega. This guy is function of omega, means it changes with the frequency. Function of omega, also the input changes with the frequency, general case in AC circuit. So what does that mean? Remember here, VO equal to V input multiplied by H of omega. And h of omega has a function with frequency like that. That's h of omega. It's like that. Okay, and this happens at 10. So what does that mean? That means if the input has a frequency less than or equal to 10, V output, you're going to have V output. You're going to see V output. And V output will be equal to V input, or maybe higher than input. But you're going to see output. But if so V input or V output will be available. If omega input, the frequency of the input voltage, I mean, is higher than 100, the output will be 0. Oh, so for low frequency, V input passes to V output. For high frequency, V input is blocked. V output equal to 0. Nothing goes to the output. Nothing transfer. Remember, this is called the transfer function. Transfer something in the input to something in the output. Okay? So V out was blocked. Nothing goes to the output. If you measure the output will be 0. The amplitude of the output will be 0. 0 voltage. Okay? 0 voltage. So basically, that's a filter. That's filtering based on the frequency. And when you pass low frequencies and reject high frequency, that's called low pass filter or low pass filtering. Okay, that's why the title here is example of a low pass filter. That's a circuit, okay, that only passes low frequencies. It doesn't pass high. Okay, guys, that's basically why actually we are concerned with Bode plots and also H of omega, just to know the behavior of the circuit according with our input frequency. If it will pass it or reject it, that's why we care about all of that. Thank you very much for watching and see you in another video. Bye.